In college algebra, we looked at some different scenarios that may happen with a system of equations. So remember that the solution is where functions intersect. So if I have parallel lines, they never cross. There's no solution. If I have two equations that are really the same equation, they're constantly like on top of each other, so it's infinite solutions. So there's two different weird scenarios there. Variables will sometimes cancel out, and it'll look really weird. Variables will cancel out, and you get a false statement. That's for no solution. So you're going to get some kind of statement like it's going to say 0 equals 3, which makes no sense. That's not true. So then you know it's a no solution. Or your variables will cancel out. And you get a true statement. So you'll get like a number equals the same number. Sometimes it's even like 0 equals 0. And if that's the case, you say infinite solutions. So no solution, you get some kind of weird false statement. Infinite solutions, you get some kind of true statement. So let's try number 5. That one looks ready for elimination. You can use either strategy if you want, but I see the variables stacked. Let's make x cancel out. So I'm looking at the 4 and the 6 here, and they have a least common multiple of 12. So let's multiply this guy by 3 to make the 4 become a 12. And let's multiply this by negative 2 so that that 6 becomes a negative 12. So I end up with 12x plus 18y equals 36. Something weird happens on this next equation. We get negative 12x, we get a negative 18, and a negative 24. And when I go to combine these, the x's go away, but so do the y's. At first instinct for me sometimes is that I messed up, and it's like, whoa, what just happened? I just made a big mistake. So check your math, but then just write down what's left, and we have 0 left. On the right, we have 12. That makes no sense. That means this is a no solution. Those two lines are parallel. I bet they have the same slope, but different y-intercept. All right, let's try another one. On number 6, this one looks like it's ready for substitution because it's all set equal to y on the first equation. And I can plug in 3 minus 2x into y. So let's do that. Copy down 4x plus 2, and then substitute in that y from above it, 3 minus 2x. Do a little bit of simplifying. Distribute that 2. And another weird thing happens. what happens to my x's? 4 minus 4, that's 0. I end up with just 6 equals 6, which is true. Check your math, make sure you didn't mess up, and our answer is infinitely many solutions. This means that those two are really the same line. If you look closely, I think that second equation is a double of the first. Like they multiplied every number by 2 and they got that second equation. All right, last problem. We are looking at this wheelchair problem. There's a company making wheelchairs, and we need to read through it and write down our cost function, how much we're out of pocket when we make wheelchairs, and how much we're bringing in when we sell them. So maybe hit pause and write those two equations. Looks like we're out of pocket $500,000 at the outset. To start a new business is pretty costly. And then it's going to cost $400 a wheelchair. So naturally, we're going to charge more than $400 to sell it because I need to make some money. And that's it for A and B. The break-even point, this is where I pay back all of my debt. So how many wheelchairs I need to sell to come out at 0. Unfortunately, I will not have made any money at that point. I'll just be out of debt. So to do this, the break-even point, just set them equal to each other. Let's say 500,000 equals 600x. Solve for x. Divide by 200. And we need to sell 2,500 wheelchairs in order to break even. If we sell 2,500 wheelchairs, we will be out of debt. Unfortunately, we will not have made any money yet. But that's about it. I'll see y'all later.